This video will focus on the graph of the inverse cosine function. It's going to look very similar to what we did with inverse sine. A lot of the same symbolism. The first graph that you see is the graph of cosine. And one thing I just want to note here is that if we think about where cosine, the graph of cosine comes from the unit circle, what we are doing is we are inputting angle measures. These are angle measures from our unit circle, and the output is actually the x values as we go through all these angle measures on the unit circle. So this gets a little confusing. Choose what you write down here, but I just want you to remember when we think about x in this function, it's the angle measures. When I think about y in this function, it's actually x values from the unit circle as we go through all these angles. Just always a good thing to kind of keep in mind. But that means when I look at my inverse function, those x and y ideas switch. Okay, so now the x-axis is actually the x values from the unit circle that correspond to certain angle measures as we go around the unit circle. So this is the weird thing. If I were to continue the graph of cosine, cosine continues to go up right there, it would actually force me to kind of draw a little piece like that. And that's the issue here, because now I no longer have a function when I think about inverse cosine. This does not pass the horizontal line test, so this will not pass the vertical line test. So again, the powers that be have decided to say, whoops, I did not mean to erase all that, but I did, have decided to say this is all that we're going to look at. This is the only part of cosine that we will consider when we decide what inverse cosine is going to be. I'm going to quick pause this, rewrite what I had up there, and then we'll move on to what this circle is for. Okay, there we go. So what I want you to note here is that when we think of inverse cosine, it relates back to this part of the graph of cosine, and we only look at angle measures from 0 to pi. And that's going to give us all the x values that go from positive 1 to negative 1. So over here, this represents the unit circle again. And anytime you have to think about an inverse cosine sort of idea, we split this up into the 4 quadrants again, we are only going to be dealing with angle measures from 0 to pi. So we only worry about the top 2 quadrants. I don't have to, at any point with inverse cosine, really deal with what's going on down here. Okay, so let's look at one quick example. I notice I have a little typo on here. It might be okay in your notes. This should really say, find inverse cosine of negative root 2 over the number 2. So just a root 2 for the numerator. And just like what we did with inverse sine, inverse cosine is asking for an angle measure. So this means for what angle measure, if I plug that angle into cosine, would I get that number as my output? So right away, I'm going to rewrite this in terms of cosine. And actually, I did not mean to do that, I don't think. Let me undo that. Okay, I want to know where cosine of theta would get me negative root 2 over 2. Okay, so on the unit circle up here, where would I get negative x values? That's going to be in this quadrant. Okay, and cosine would produce a root 2 over 2 at a 45 degree related angle. So it can't be here. It means it's got to be this 45 degree angle right there. Again, I want you to think in terms of radians, but if the first thing you thought of was degrees, that's fine. That means theta would have to be 135 degrees. Again, that's the angle measure that gets me that 45 degree angle in the second quadrant. But in radian measure, that's going to be 3 pi over 4 radians. Okay, so any of these would be acceptable answers. Let me fix that A a little bit. There we go. Again, very quick, simple intro into it. Jot down questions you might have.